In this video, we are going to discuss how to solve rational equations. Now remember, a rational equation is an equation where you have fractions and you have polynomials in both your numerators and your denominators. To solve these rational equations, you want to eliminate your denominator first. So in order for us to eliminate our denominator, we're going to multiply each term by the common denominator. So we're going to start very simple. So I have a denominator of 3, 6, and 2. So my LCD of these three denominators is 6. So that means I'm going to multiply every single one of these terms by 6. When I do that, this is only getting multiplied to the numerator. So I can cancel out and then multiply. That's how we want to always get rid of our denominators. We want to get rid of our denominators by multiplying by the common denominator to then cancel it out. So 6 over 3 reduces to 2. 6 over 6 reduces to 1. 6 over 2 reduces to 3. So what I am left with now is 2 times a minus 4 plus 1 times 11 equals 3 times a plus 1. That is our goal. Our goal is to eliminate the denominators. We want to get rid of them altogether and have a simple linear equation. So now to solve for a here, I'm going to distribute 2a minus 8 plus 11 equals 3a plus 3. Combine like terms, 2a plus 3 equals 3a plus 3. Subtract the 2a on both sides. I now have 3 equals a plus 3. Subtract the 3 on both sides. Ends up canceling on both sides, so I'm left with a equals 0. Now we always have to make sure we double check our answer into our denominators. Since we had numerical denominators, our answer actually does not make any of our denominators undefined. So we can say a equals 0. In intermediate algebra, we always put our answer with brackets. So our final answer is a solution set of 0. So that was one where we had numerical denominators. Now let's try one where we have variables and numbers. So 5 over 7t equals 52 over 7 minus 3 over t. So I have 7t, 7, and t. My common denominator here is 7t. It must be a combination of all denominators. So this is what I'm going to multiply each term by to get rid of the denominators in this question. I keep the minus sign inside this parenthesis just so I remember that I have subtraction here. Now let's simplify. 7t over 7t cancels each other out. 7t over 7, the 7's drop out. And 7t over t, the t's drop out. So now I am left with, this became a 1, I'm left with 1 times 5 equals t times 52 minus 7 times 3. Okay. 5 equals 52t minus 21. Add the 21 to both sides. I have 26 equals 52t. Divide both sides by 52. So far I have t equals 26 over 52. I put that into my calculator to see if it can reduce, and it can. I can divide top and bottom here by 26. So my final answer is t equals 1 over 2 for a solution set of 1/2. So number 1, we had just numerical denominators. Now I have here numbers and variables. take our answer, we double check. 7 times a half does give me an integer. And right here I get 1/2. None of them provide me with a denominator of 0, so our answer can be 1/2. Now let's go a little more difficult. Let's try binomials in our denominators. Before I can figure out what my common denominator is, though, I would have to factor everything. So for 3k plus 9, let's take out a 3. That leaves me with k plus 3. So we're done with that. That denominator has now changed from 3k plus 9 to 3 times k plus 3. 15 I can't change. 5k plus 15, I can take out a 5. That again leaves me with k plus 3. So 5k plus 15 factored to 5 times k plus 3. Now to figure out this common denominator, I have to look at the binomials and the numbers. I have 3, 15, and 5. Of those 3 numbers, the common number would be 15. Then I have k plus 3 and k plus 3. I have to include all pieces of all denominators for it to be considered the least common denominator. So my least common denominator of this equation is 15 times k plus 3. So that's what I'm going to multiply every single term by. 15 times k plus 3. 15 times k plus 3. 15 times k plus 3. So I'm going to reduce. For the first term, the k plus 3's drop each other out. 15 over 3. All I'm left with is 5 for the first term. Negative 18 fifths. 15ths, excuse me. The 15ths drop. I'm left with now negative 8 times k plus 3. And for the last term, I have k plus 3 dropping each other out. 15 over 5 leaves me with 3. So my new equation now is 5 times 8 minus 8 times k plus 3 equals 3 times 2. Distribute. So 40 minus 8k minus 24 equals 6. 40 minus 24 can be combined. That leaves me with 16. So negative 8k plus 16 equals 6. Minus 16 minus 16. Negative 8k equals negative 10. Divide both sides by the negative 8. I have k equaling 2 negatives make a positive, so 10/8, which is not in lowest terms. So in order to write it in lowest terms, we have to divide top and bottom by 2. So I finally get k equals 5/4. And again, since we're in intermediate algebra, we write our answers as a solution set. So our solution set is 5/4. And I can plug those in, and I do not get any zeros in my denominators. So make sure you have to continue to multiply each term by the common denominator in order to eliminate the denominators and create linear equations. Okay, one more. Our last equation, 2 over y plus 1 minus 3 over y squared minus y minus 2 equals 3 over y minus 2. Again, to find my common denominator, I do need to factor. So I'm going to factor the inner term. I have here a binomial and here a binomial. That's probably going to be part of this trinomial. So when I factor y squared minus y minus 2, I do get y plus 1 times y minus 2. Okay, so that has been reduced. They share and they share. So my common denominator is this entire expression. Do not FOIL it back. Leave it in factored form. So my common denominator for number 4 is y plus 1 times y minus 2. That whole expression is what I'm going to multiply each term by in order to eliminate the denominators. So y plus 1, y minus 2, y plus 1, y minus 2, y plus 1, y minus 2. And I continue the same process I've been doing with 1, 2, and 3. I eliminate anything they share. So for the first term, they both share y plus 1, so all I'm left with is 2 times y minus 2. Next, the y plus 1s and the y minus 2s drop each other out. So all I'm left here is just minus 3, and since it canceled out, that becomes a 1. Equals. The last term, the y minus 2's drop each other out, so I'm left with 3 times y plus 1. Okay, now I have to do some distribution. 2y minus 4 minus 3 equals 3y plus 3. Combine like terms over here. 2y minus 7 equals 3y plus 3. Subtract the 2y on both sides. Negative 7 equals y plus 3. Subtract the 3 on both sides. Negative 10 equals y. Going back to my original, I can plug in the negative 10 to all 3 denominators, and I do not receive an undefined. If my answer by chance did, when plugged in, give me a denominator of 0, I would have to reject the answer and say I have no solution. But here it works. So y equals negative 10. We write that as a solution set in braces of negative 10. So there we have solving rational equations. Always multiply each term of the rational equation by the common denominator of the entire equation. You must look at all denominators to figure out what the common denominator is.